Today's lesson is from your Math Focus 7 textbook, section 1.8, which is on page 30. Our goal with this lesson is to identify and extend number patterns to solve problems. Let's start with this problem. Megan has more than 100 songs on her phone. The number of songs on her phone has a remainder of 1 when divided by 2 or 3. What is the least number of songs that Megan could have on her phone? So we know the number has to be more than 100, probably just a little bit more than 100, and have a remainder of 1 when divided by 2 and 3. So what's the first number greater than 100 that has a remainder of 1 when divided by 2? 101. I know 100 is divisible by 2. So 100 plus 1 equals 101, and it must have a remainder of 1 when divided by 2. So what are the other numbers greater than 100 that will have a remainder of 1 when divided by 2? If we go to the next number, 102, using our divisibility rules, we know that any number ending in 2 is divisible by 2 because it's an even number. So we know it can't be 102. If we go to 103, we know because it ends in 3, it's an odd number, not divisible by 2, so 103 would also have a remainder of 1. If we go to 104, again, using our divisibility rules, we know that this is an even number, so it would divide by 2 with no remainder, so it can't be. So what I notice about this is that the odd numbers do fit our criteria. They have a remainder of 1 when divided by 2, and the even numbers do not, because they would have no remainder when divided by 2. So our numbers over 100 with a remainder of 1 when divided by 2 are 101, 103, 105, 107, 109, and 111. So all odd numbers. Now the second part of the question is that it also has to have a remainder of 1 when divided by 3. So what are the numbers over 100 with a remainder of 1 when divided by 3? Using our divisibility rules, let's think of the number closest to 100 but just slightly over that is divisible by 3. What's a number over 100 whose digits add up to a number divisible by 3? Now remember, our divisibility rule for 3 is that the sum of the digits have to equal a number that's divisible by 3. So with the number 102, we're saying 1 plus 0 plus 2, which equals 3, which is divisible by 3. 3 divided by 3 is 1. So we know that 102 is divisible by 3. So if we needed a remainder of 1, we'd have to go 1 more than 102. And we end up with 103. Lucky for us, we found our matching pair right away. But what if we hadn't? What would we have to do if we wanted to find more numbers over 100 with a remainder of 1 when divided by 3? We'd have to find numbers that were divisible by 3 and then add 1 to them. So 102 was divisible by 3 because 2 plus 1 equals 3. The next number that would be divisible by 3 would have to be 1 plus 0 plus a number here that would equal a number divisible by 3. 105. 5 plus 1 is 6, so 105 is divisible by 3. So if we wanted to find a number that was over 100 with a remainder of 1 when divisible by 3, we would have to add 1 to a number that was already divisible by 3, ending up with 106. So overall, what is the solution to our problem? The solution is 103, because 103 has a remainder of 1 when divided by 2, and it also has a remainder of 1 when divided by 3. Read through the example on page 30 in your textbook and complete the reflecting section on page 31.